Hey, everybody. How's your day going so far? Cool. So originally, this talk was going to be about rewriting ease.com with Next.js, and it kind of deviated into sort of a brain dump, and not a very organized one at that. So I'm going to start off by introducing both myself and Ease. I'm going to talk about Ease before and after migrating to Next.js. And finally, I'm going to talk about some of the tooling that Next.js and Now has enabled for us. So my name is Jack Hanford. I've been writing JavaScript professionally for about 5 years. I was the first software engineer at Ease. I was employee number 5, and I've been there for just about 3 years. So what is Ease? Well, Ease is a tech company that facilitates on-demand marijuana delivery. And when I say on-demand, I mean it. The majority of our deliveries are happening in under 20 minutes. CNBC once did a segment called Pizza versus Pot, where they ordered marijuana and pizza at the same time. And it turns out in San Francisco, you can get marijuana delivered faster than you can get pizza delivered. Yeah, what a time. So Ease operates in 30 cities in California. We have about 130 employees, 30 of which are software engineers. Deliveries are happening every 10 seconds. And Ease is a mobile web company. And that's what I'm going to focus on. So 80% of our traffic is coming in on a mobile device, and that's a pretty unique opportunity. What's often an afterthought is our primary audience. We have 5 large React.js applications, ease.com, some internal ones, and then a B2B one as well. We have 2 React Native apps. We have a driver app and a consumer app. And in our consumer app, you can really only browse our catalog or kind of look at our blog. The app stores don't allow cannabis sales. Google and Apple have different rules. And they're broad rules. They're open to their own interpretation. Sometimes they're open to the app reviewer's interpretation. So the ease.com front end has gone through 3 rewrites with 3 different frameworks in 3 years. And that's a testament to how fast-paced JavaScript is moving. So which frameworks? Well, initially we chose Angular 1. Two-way data binding was really great until your application grew. It was also really hard to have good SEO with Angular 1. And so we switched to a much smaller framework called Mercury. Mercury is kind of a framework that's composed of a lot of NPM micro modules. You can bring your own virtual DOM or bring your own data management library. We couldn't really scale the team with it because nobody knew how to contribute quickly. And so we chose React. React, easy to hire, easy to scale a team with, good performance, great ecosystem. With React, you're kind of standing on the shoulders of giants. Facebook's been pretty public about having over 50,000 React components. And our goal was for new hires to be able to make contributions on day 1. So Ease meets React. This is kind of a pre-Next.js portion. Right after choosing React, we were super excited to bootstrap our new repo and start coding. But what happened is we kind of got slapped in the face with some front-end build infrastructure. And at some point, this was very real, where I felt like I was spending my entire day just kind of tweaking and configuring Webpack. We had all of these very complex build scripts. This was all in I think 2016. It was a couple weeks before Create React app came out, unfortunately. And so if you remember, there was tons of these different GitHub repos that were super bloated. And so we chose to just start a new project from scratch. We had a custom CI deploy process, custom server-side rendering, which I'm going to go a little bit deeper into in a moment. We had a custom CSS config. It was some weird combination of extract text plugin, CSS modules, post CSS, style loader. We didn't have any hot module reloading for CSS or for JavaScript. On top of that, we had a really inefficient build process. We had really hot computers with no battery life. And that made building our application non-trivial. So I went into our repo a couple days ago, and I did git reset, had 5,000 commits, and npm-i, npm start, and this was the result. So as you can see, my computer's idle, and Node is just chomping away at 150% of my CPU, just watching all of these JavaScript files, rebuilding all of them, whenever we save one. And so as the team grew, so did this kind of tribal knowledge. And a coworker and I were constantly pointing at each other for various parts of the application that we weren't as familiar with, just to try and unblock some of the newer teammates. On top of that, we had some really rough parts of our application that were super brittle, and as a result, developers were afraid to modify them because they didn't want to break them. Enter Next.js and now. So why did we choose Next? Well, React wasn't the problem, the lack of structure was. Out of the box, Next comes with a lot of really well-defined boundaries. Now would help reduce our DevOps dependencies, and it would let the front-end team own the front end. Next would give us a faster development speed with hot module reloading. Both would help us serve our website faster. So here's kind of a look at Webpack before Next.js. Lots of kind of weird stuff going on. Webpack was spread across many files. We were doing this kind of weird non-standard composition. And switching to Next.js reduced our Webpack code by about 80%. And on top of that, we were able to accomplish a lot more. Hot module reloading is one, but there's a few other easy wins that we got as well. Deployments are kind of the same story. So before Next.js, we only had 2 environments, development.ease.com and then ease.com. And this didn't really scale past, you guys see that? There's like a bug flying around. This didn't really scale past a couple of front-end team members. There's lots of coordination between front-end and product just to try and see work outside of localhost. So we also switched off of BuildKite onto a different CI, Circle CI. So full disclaimer, that was woo, that was part of the code reduction as well. But we got way simpler code, and with now we got these infinite immutable environments. So here's a look at server-side rendering before Next.js. This is just a very small chunk of that code. I actually couldn't fit all of the server-side rendering code that we had on one slide. And so I just took a little screenshot of part of it. But as you can see, this is some pretty complex stateful code. This was in our Redux map state to props. And you can see that data could be coming from 4 different places. It could be coming from the window object. It could be coming from our rendering service, or it could be coming from our application's Redux state. Or maybe the data is just not even there. Maybe it's a 404. And so we weren't really server-side rendering that many pages because it was so complex and so manual. And as a result, we weren't server-side rendering our any pages in our core flow. So we had these SEO pages, what we called them. They were for products or for brands. And they were only really around so we could try and game SEO and show up higher in Google. But because they weren't part of the core flow, they would break and we wouldn't know. We wouldn't know until either an employee or a user would tell us, which frankly is a pretty embarrassing state to be in. And so here's server-side rendering after Next.js. It's 12 lines of code doing the same thing. It was really great to be able to just delete everything I was just showing you. And so right now, we've talked about how Next.js and now have improved Webpack, our deployments, and also server-side rendering. What else did we get? Well, previously, we had a static application, and it was super frustrating because people would open ease.com on their computer, or pin the tab, or close their laptop lid and come back a couple weeks later, and then start throwing a bunch of exceptions on our website. And so our Sentry was just filled with errors from previous versions of our site. And that was pretty frustrating because we had already fixed a lot of those bugs. And so on messenger.com, you get prompted to update, or I think Gmail or Inbox does that as well. And we wanted to be able to do that. So because we're using Next.js, it was really easy to just create a status endpoint that returns a commit hash of whatever we've deployed. After we deploy, the new node server will just return a different commit hash because it's changed. And because the front end would be pulling this endpoint, we could then prompt the users to update. And so all of our users are on the latest code within minutes, which was a really great win for us. And so one day after we had switched to Next, we noticed all these options requests that were in the network tab. And it was because our API lived on a subdomain, and we were sending all these non-standard headers too. And these options requests are taking 100 milliseconds each. And these are on post requests, get requests, any request that has these non-standard HTTP headers. And so with a couple lines of JavaScript, we were able to just proxy all of our API requests through the front-end server. And so the browser thinks it's just talking to ease.com's node server, when in reality it's talking to like api.ease.com, totally different service. So we discovered that we could fix this with just by proxying. All of our API requests were being passed through this proxy, which meant that there was no DNS lookup to the API, no new TCP or SSL handshake to the API, and most importantly, no pre-flights. So this sped up every request by about 150 milliseconds, which was a very noticeable change in our application. So next, I want to talk about client-side performance. I was pretty curious like 6 or 7 months ago about how we could like best test or measure client-side performance. It turns out everything that you need is just on the window object. So this is how we're calculating the time till interactive, DOM content loaded, and load complete events. And at ease, we just have a little React higher order component that does a little track call and sends all of this data to Segment. So we can see the performance that our users are seeing. So here's before and after performance from our application. As you can see, performance is noticeably better. Also, more importantly, the perceived performance was way better because the server is rendering most of our pages, and this means that there's no solid white screen while the browser is downloading, parsing, and then bootstrapping our JavaScript. So now I'd like to talk about some of the tooling that Next has enabled for us. So we have this little tool at ease called BundleCop. BundleCop is a bundle size comparison between 2 branches. And so we trigger this thing on Circle CI. It builds our application on a feature branch, and then on master, we pass a couple of flags to Webpack. And instead of like building our application, it'll just put all of the information into a JSON file. And so all BundleCop does is compares 2 of these big JSON files. And I want to show it to you guys. This might be kind of hard. Cool, yeah, so this is BundleCop from one of our PRs from a while ago. You can see that there's like these like larger bundles, and then down here there's these like smaller bundles. And inside of BundleCop, you can just define a threshold. Say like we don't care about like 0.0% changes in our application. So you can see like that's like a very small one. All right, so I think I can close this. Cool, so that's one of our tools. The next one is called E2Ease. So this is our integration test suite for ease.com. We traverse the core flow with Puppeteer, and then we take screenshots every step of the way. We then, on top of that, we also emulate a mobile browser and just do the same thing. And so I want to show you that as well. Both of these are now static deployments. And so these are running on CI. And so you can see this is like an earlier version of it, but this is every part of our application, both on desktop and then down here is on mobile. And so because these things are running on CI and because these are now deployments, we just capture that link on CI and then we post it to every PR. And this is super valuable because any engineer can then open E2Ease and they can see that the core flow works. Then that front-end engineer can double check that they're not accidentally ballooning the bundle sizes. And finally, they can just send over that build to QA if we want to do some manual testing. So I've talked about how Next and Now have helped simplify Webpack, deployments, server-side rendering. It's increased our application performance. It's helped a lot with end-to-end testing and bundle size comparisons. Thank you so much for letting me talk about Next.js. And if you're interested in BundleCop, it's on my GitHub, but that's all I got.